Okay, the next strategy that we're going to look at is if you have an integral like this, um, you would really have a hard time doing anything with this one unless you worked a little bit with some algebra. So what we're going to do is multiply by 1, which means we're going to multiply top and bottom by some value that'll help us a little bit with this expression. So actually what I'm going to do on this is I'm going to rationalize the denominator and just see where that leads me on this. So let's go ahead and just kind of at the side work with this. So we got 1 minus x, 1 minus square root of x, and the conjugate of the denominator, remember, is going to be 1 plus square root of x, and 1 plus square root of x. We're going to multiply top and bottom by that. Okay, when we do this, okay, the numerator is just going to remain the same. Okay, when you multiply out the denominator, by FOIL, you're just really doing the first term. 1 times 1 is 1. Negative square root of x, you're really getting negative square root of x squared. So you get 1 minus x over 1 plus square root of x all over 1 minus x. Okay, so you got to be sure that you're comfortable with the algebra, working with radicals, multiplying out binomials. Now that will cross out, leaving this. Okay, so that means when we do this integral, we're just going to change this integral to the integral of 1 plus square root of x times dx. Okay, like that. All right, well, I'm going to write this as 1 plus x to the 1/2 power, and then this is a real simple integral, no use substitution, just apply basic rules. So we're going to do the integral of 1 dx plus the integral of x to the 1/2 dx. So the integral of a constant is just x, okay, because the derivative of x is 1. Then you use the power rule, so you add 1 to the exponent, so I'm going to add 2 over 2, divide by the result. The result of that's 3/2. Then you have plus c, and then we'll just kind of clean it up a little bit. So we have x plus, and we're dividing by 2/3. If you divide by 3/2, you're multiplying by 2/3. So it's going to be plus 2/3 x to the 3/2 plus c. Okay, then that should be your solution to that problem then. Now, if you wanted to, check this is a pretty simple one to do. So if you did the derivative of the answer, the derivative of x is 1. The derivative of this next term is you'd write down the constant 2/3, power rule, so that would be 3/2 x, and then subtract 1 from that. So you're going to have 1 plus, and notice that goes to 1. 1 times x to the 1/2. So that's 1 plus square root of x. And that's what we had there. Okay, so that one checks out. So we have our official answer to the problem right here. Okay, now let's do this next one here. Again, this one, you want to think about trying to multiply by a conjugate and just see what happens. Now with this one, I'm going to go ahead and I'm going to work with this for a while here, and I'm just going to write it down before we even get to doing the integral. I'm just going to work over at the side here with some of the algebra. So we're going to work with 1 over secant x minus 1. And what I'm going to do is I'm going to multiply this by secant x plus 1 over secant x plus 1. Okay, so that is going to give secant x plus 1 in the numerator. The denominator is going to multiply out to give secant squared x minus 1. If you do the FOIL and everything, that's what you're going to get. Okay, now we have an identity that we can use that goes like this. I'll just write this identity aside. The identity of tangent squared x plus 1 equals secant squared x. So that's one of your basic trig identities. Trig identities you got to kind of work with every now and then because they'll show up when you're working with trig integrals, and a lot of times you have to use those a little bit. Okay, so I'm going to replace this. Okay, so notice if I move this one to this side, I get tangent squared x equals secant squared x minus 1. So I'm going to replace this whole thing with this. Okay, so that's going to leave me with secant x plus 1 over tangent squared x. Now keep in mind, we're going to be integrating this. This still looks like a really complicated integral. All right, when in doubt, change everything to sines and cosines. So I'm going to change the secant to what it's equal to. It's equal to 1 over cosine x. Okay, so I do that. I'm going to change the tangent to what it's equal to. We have an identity for tangent. Remember, that is the sine over the cosine, so that's going to be sine squared over cosine squared x. Now I have a complex fraction, so I'm going to, since I need to get rid of a cosine and a cosine squared, I'm going to multiply by cosine squared x. Okay, like this, and we'll see where this leads us. So cosine squared x times cosine. One of the cosines is going to cross out, so that's going to leave, cosine x. Okay, and then cosine times 1 would be cosine squared x. And then the bottom, the cosine squared x's are going to cross out, and that's going to leave that then. Okay, so let's see kind of where we're at on this now. Okay, so just kind of completing this now, I'm going to try to break this up now and work with this. We're getting closer to being ready to do our integral like this. So what I'm going to do is slide this down just a little bit here. And I'm going to now break this up like this. Cosine x over sine squared x plus cosine squared x over sine squared x, like this. Okay? Now, I'm going to write this. Now, there's a reason why I'm doing this. I'll explain that as soon as I get to that point. I'm going to write this as this. I'm just kind of looking at my integrals, and I'm seeing if this will match with some of my integral rules. So I'm going to write this cosine x over sine x times 1 over sine x. And I'm going to write this as cotangent squared x. Okay. Now I'm going to write this. This is cotangent. And then this is cosecant x. Okay, like this. And one thing that you'll notice on this is one thing that we know, like if you kind of think about your derivative rules, is a couple of things. We know the derivative of the cosecant. The derivative of the cosecant is negative cosecant x cotangent x. So that means that's going to be a real easy thing to integrate. And then the cotangent, well, one thing that we know about the cotangent is we have an identity from trigonometry. We have the identity that says the cotangent squared theta plus 1 is equal to cosecant squared theta. Okay, so I could write this. The cotangent is going to really be the cosecant squared x minus 1. Now, why is that important? Well, because there is a trig function that we differentiate. Namely, if you do the derivative of the cotangent of x, you get negative cosecant squared x. Okay, so that's something that we can integrate there, and then of course we can integrate 1. Okay, so all of that trig manipulation, everything that I did right there, is basically just playing around with this until you get something that'll match up with one of the rules. So we're going to rewrite this as the integral of cotangent x cosecant x plus cosecant squared x minus 1 dx. That's what we're going to work with. Okay, and the key thing is that I want to kind of write on here is, again, we know the derivative of the cosecant of x is equal to negative cosecant x cotangent x. Okay, so see, notice this thing matches almost with that. It's off by a negative, but we can deal with that okay. So I'm going to go ahead and break this up into several integrals. I'm going to say integral of cotangent x cosecant x dx. Then I'm going to put this together. Okay, the reason I'm doing that is because we have this rule. Derivative of cotangent is negative cosecant squared x. So I'm going to write this as integral cosecant squared x dx. Then I'm going to do the integral of 1 dx, which of course is a breeze to do. Okay, well, if you look at this, cotangent cosecant, that doesn't quite match the rule. The rule has a negative in it, but we can be sneaky, and we can put a negative there and a negative there. Same thing here. We have the derivative of the cotangent is negative cosecant squared theta. All we have is a cosecant, so we can be sneaky and put a negative right there. Okay? Now we're in business. It's actually very easy to finish this thing up now. Okay, the answer is going to just pop right out then. So we're going to have negative. Okay, the value of this integral right here is going to be equal to the cosecant. Okay, so that's going to be negative cosecant x plus, then we got that negative that comes down, and then we know that the derivative of the cotangent is the negative cosecant. So I meant to put a negative there. So that's minus cosecant, or cotangent, x, and then the integral of 1 of a constant is just x plus c. So the final answer of this problem is negative cosecant x minus cotangent x minus x plus c. A lot of work. That's a tough one. And that's what you get into in some of these trig integrals, just kind of like a puzzle. If you took trigonometry and pre-calc, one of the things you learned how to do was work with identities. You did verifying identities. This is what it kind of prepares you for. So that would be the solution to that then. Okay?